Now we get to the portion of the class where we're going to collect an unreasonable number of shift assembly instructions. So let's start with a simple example of an unsigned long ABC, set A to 5, shift A over by 4 bits to the left, and set that equal to B, and then shift B over by 3 bits to the right, and set that equal to C. What kind of assembly do we get from that? Well, we get 2 new assembly instructions, which I have decided to adopt and call silly and surly. So silly, shift left, logical by immediate. Silly is actually 2 assembly instructions, a 32-bit version and a 64-bit version. And while they're both called silly, one of them shifts by 5 bits for 32-bit registers, and one of them shifts by 6 bits for 64-bit registers. And those values should make sense to you because 2 to the 5 is 32, and 2 to the 6 is 64. Therefore, it doesn't make sense to shift the bits further to the left more than 32 bits for a 32-bit register, or I should have said 31 bits for a 32-bit register, or 63 bits for a 64-bit register, because of course they encode 0 to 31 and 0 to 63. So the silly instruction just takes the source register and shifts it left by however many bits is specified by these 5 bits. It's not shifting by 5 bits, it's using 5 bits to encode the values 0 through 31. So shift it left and store that result in the destination register. Now this is a logical shift. In a logical shift, you fill in the shifted bits with zeros. We'll show that in a second. And this is a left shift, meaning that it's going to be those least significant bits as we shift over to the left. So let's draw a picture of that. Let's assume that we had silly of A4, A5, 12. That's going to take the A5 register, shift it left logically by 12 bits, and put the result into A4. Let's assume that when this assembly instruction is about to be run, we have A5 holding stabba-dabba-doods again. And we are then going to shift it left by 12, and that yields the following result. 12 bits at the bottom are set to 0. These bits from the least significant bits are shifted up by 12 bits, so what was bit 0 becomes bit 12, and the bottom bits 0 through 11 are now all zeros. And these upper 12 bits just kind of fall out of the side of the register and get lost to history. So the net result is that we have this bada dudes or whatever it is. Anyways, just 12 bits of zeros show up at the bottom and everything else is shifted to the left and you lose the top 12 bits. That's shift left logical by an immediate. Shift right, logical by an immediate, or surly, is the same thing, just going the opposite direction. You have a source, and if it's 32-bit, you're going to shift it by 0 to 31, and if it's 64, you shift it to the right by 0 to 63. And so, yeah, just everything is the same. It's a logical shift, so it is always filling it in with zeros. And because this is shifting to the right, the filling happens at the most significant bits rather than the least significant. So surly A4, A5, 12, A5 once again, stabba-dabba-doods. Shift right by 12 and you get this. The most significant bits are shifted down by 12 and the upper 12 bits are filled in with zeros. Always zeros for a logical shift. Okay, well that was shift left and shift right, logical by immediate. Surly and silly. Go ahead and stop and step through the assembly and make sure you understand how it corresponds to the C source code that you were given.